A unit rate is a special rate where one of the quantities in the ratio is being compared to 1. Unit rates are typically used to find things like unit price, which means price per pound, or unit speed, which can be represented by miles per hour. Unit rate problems can be solved in a variety of different ways, including using tape diagrams, number lines, and proportions. So let's look at a few examples. Maggie walked 8 miles at a constant rate for 2 hours. What is her unit rate of speed? Well, if I want to use a tape diagram, I want to set it up using fraction bars. I'm going to start with the miles that Maggie walks, and I'm going to use one fraction bar to represent the total number of miles. And because I know that she walked 8 miles, I'm going to split that fraction bar into 8 equal pieces. Now I'm going to look at hours. I know that Maggie walked 8 miles in exactly 2 hours, so I'm using the same fraction bar because this is how much she walked. And I'm going to split this one into 2 pieces to represent the 2 hours that it took her to walk the 8 miles. To find the unit rate of speed, I'm going to look at 1 hour. So in 1 hour, I notice that 1 hour takes up all of this time. And this time is 1, 2, 3, 4 miles. That means that Maggie walks at a constant speed of 4 miles per hour. Next, Harvey purchases 3 pounds of chicken for $9. How much would 4 pounds of chicken cost at the same rate? If I want to use a number line for this, then I'm going to start with what I know, which is how many pounds of chicken Harvey purchased. I know that he purchased 3 pounds of chicken, so I make a number line that goes from 0 to 3. I also know that those 3 pounds of chicken cost $9, so I'm going to make a number line right below it with the cost. And I don't know how much 1 or 2 pounds of chicken cost, but I do know that my 3 pounds of chicken cost $9. So my 3 would be right above my 9. If I look at my first number line, I notice that it's split into 3 equal pieces. So my second number line should also be split into 3 equal pieces. And to figure out the interval that is going to be used for this number line, I would take my 9 and divide by 3. And when I do that, I get 3. That means that each one of these is going to increase by 3. So I should have 3 and then 6 on my number line. Now to answer the question, it says how much would 4 pounds of chicken cost? Well, if I'm going at the same rate, then I can extend my first number line to go to 4, and I can extend my second number line so that it goes right below 4. I know that in my second number line, each of these is increasing by 3, so I'm going to take 9 and add 3, which would give me 12. So I know that 4 pounds of chicken would cost $12. Next, the Fernandez family is visiting their friends in another state. After 8 hours, they have traveled 584 miles. What is their unit speed? When I'm being asked for unit speed, if I know that I'm looking at miles, then I'm going to be looking at miles per hour. In this case, I know the family traveled 584 miles in 8 hours. So that would go in my first ratio. Next, because I'm looking for miles per hour, I don't know how many miles that would be, so I would use X to represent miles. And when I see per hour, that always means 1. So I'm looking for how many miles I travel in just 1 hour. My ratio can be 584 over 8 equals X over 1. I do this because 584 miles were traveled in 8 hours, so those should be in one ratio. On this ratio, I don't know how many miles, and because I have miles in my numerator here, miles must be in my numerator over here. What I do know is that I'm looking for how many miles after 1 hour. And because I had hours in my denominator on this ratio, hours should be in my denominator on this one. Now to figure out what x equals, I'm going to look at how did I get from 8 to 1. I know that these are equivalent ratios, which means that they really are equivalent fractions. And to get from 8 to 1, I would have divided by 8. So 8 divided by 8 would give me 1. Now, because these are equivalent fractions, if I divided my denominator by 8, then my numerator would have also been divided by 8. So I would do 584 divided by 8, which would give me 73. So x equals 73. And this means that the Fernandez family travels 73 miles per hour. Next, Jayden rides his bike at a constant speed. He travels 4.2 miles in 3 hours. What is his unit speed? So I know that Jayden travels 4.2 miles, and I always label this what goes in my proportion. So he travels 4.2 miles in 3 hours. So that's my first rate that I'm going to put in a ratio. Now I'm going to set it equal to what I'm looking for next, which is unit speed. Unit speed, again, means miles per hour in this case. I don't know how many miles, so I'm going to put x for my number of miles. I do know that I'm looking for per hour, which means 1 hour. Again, notice that I have miles in my numerator here and miles in my numerator here. Since hours are in my denominator over here, I have hours in my denominator over here. Now, to get from 3 to 1, I would have divided by 3, which means that to get from 4.2 to x, I would also have to divide by 3. When I do 4.2 divided by 3, I get x equals 1.4. So this means that Jayden travels at a speed of 1.4 miles per hour. If Lynn can build 12 birdhouses in 4 hours, how many birdhouses can he build in 6 hours? Well, for this, I know that my first rate is that Lynn can build 12 birdhouses in 4 hours. So my first rate is 12 over 4. Then I'm being asked how many birdhouses can he build in 6 hours? Well, since I have hours in my denominator over here, I need to have hours in my denominator over here. And what I don't know is how many birdhouses. So I'm going to use the variable x to represent that. Now, to get from 4 to 6, I know that I'm multiplying because in order to change on fractions, I know that I'm either multiplying or dividing. And since 6 is larger than 4, I'm multiplying. But what am I multiplying by? Because 4 times 1 is 4 and 4 times 2 is 8. So if I'm doing this and I need to know what am I multiplying by, I can actually take 6 and divide by 4, and I'm going to get 1.5. Well, that means that I would do 4 times 1.5 to get 6. Now I'm going to do the same thing here to get x. I'm going to take my 12 birdhouses and I'm going to multiply by 1.5. So 12 times 1.5 gives me 18. That means for this problem that Lynn can build 18 birdhouses in 6 hours. Allie and Jay are driving at a constant speed. After 6 hours, Allie has driven 408 miles. After 8.5 hours, Jay has driven 544 miles. Who is traveling at the fastest rate of speed? For this problem, because it's asking me to compare, I'm going to have to find the unit rate for both Allie and Jay. So I'm going to start with Allie. I know that she has driven 408 miles, and she has done that in 8.5 hours, or 6 hours, I'm sorry. What I'm looking for is her unit speed, which I don't know how many miles that is, but I know that I'm looking for in 1 hour. So For this, to get from 6 to 1, I would have divided by 6. To get from 408 to x, I would also have to divide by 6. So when I divide by 6 here, I get 68. That means that Allie's speed is 68 miles per hour. Now we're going to do the same thing for Jay. Jay travels 544 miles, and he does that in 8.5 hours. I'm going to find how many miles, so I don't know, so I'm using the variable x to represent it, in 1 hour. Now, to get from 8.5 to 1, I would divide by 8.5. So that means that to get from 544 to x, I would also divide by 8.5. So when I do 544 divided by 8.5, I get 64. That means that J travels at a speed of 64 miles per hour. To answer the question, who is traveling at the fastest rate of speed? Allie is traveling at the faster rate of speed because she is traveling at 68 miles per hour, and Jay is only traveling at 64 miles per hour.